Thank you. I'd like to share with you this afternoon an issue that is really related to the assessment of research quality. This is what Professor Ranganath asked me to speak about, and the challenges that this offers. Now, as all of us are aware, NAC has a set of 7 different criteria that it uses for assessment and accreditation. So what I'm trying to focus is on number 3 of this set of 7 criteria. The research quality essentially would depend on the productivity of research, how much is its output, but also the quality and the impact of the scholarship. What would be the innovation that this research has brought about, and what might be the social benefits that would derive from this kind of evaluation? It's quite clear that no single set of indicators can actually capture the complexity of research. And when we are talking about research, one of the problems you face is when you actually try to look at quality across different disciplines. For instance, if you look at, let's say, the natural sciences, life sciences, engineering, and so on, primarily, most of the research is communicated through peer-reviewed journals. But what might happen is that, let's say, if you have, people who are doing scholarly work in other areas, say for example in the area of fine arts, they would not normally be assessed on the basis of what they would publish in a journal. But then how do you assess the quality of that research? How do you evaluate the creative kind of energies that go into that sort of work? And people who are from the social sciences and humanities, sometimes they have book chapters which are equally scholarly, monographs, and so forth. For those people who are in the technology area, making an artifact, making a kind of a prototype of a machine might be a part of their research. So the question is, you have a whole gambit of these different disciplines when you are talking about measuring research output. And so this is a challenge that you have when you have this assessment, and therefore based on this accreditation. Let me just talk a little bit about the challenges in science. This is taken from a newspaper. The question is not, is there a God, but really the fact, which is the second part, which is that India accounts for a very small percentage. This was published in September 2012. That India accounts for just about 3.5% of the global research output. When we are talking about accreditation and quality, and NAC has always benchmarked its quality by looking at international standards, we need to keep in mind this fact that we have a really long way to go. Because, compared to China, comparisons to China somehow seem to be inevitable. That output is about 18%. India is about 3.5%. So when we talk about quality in a kind of a, quantifiable term, even just for the sciences, it's quite clear that the gap is very large. So when we are talking about our quality institutions, even out of that 3% or so, there is generally an agreement that probably not more than 1 or 2% of the research output, in fact, has a real international impact. So in that kind of a situation, one would have to really kind of ask what constitutes good science. And these are all, anecdotal. It's not that necessary that we all agree to that, but there's a certain hierarchy in how people look at, the importance or the impact of scientific research. It has to be novel, which means that it must not resemble something that existed before. It could be novel, but it may not be important. So sometimes when you are actually making an assessment, You look at whether something that you assess is important. But in scientific research, it can very often be that you have charted a new course, but its importance is not yet realized. And this, I mean, there are umpteen examples from the field of biology that I am familiar with, where you can know of discoveries whose true import was not known, sometimes even till 50 years after they were discovered. And I understand from friends from physics and so on, that's the case there as well. The second level in terms of how science is done is more mechanistic, which is to test a hypothesis, determining a fundamental process which is involved in or is responsible for a reaction or any other natural phenomenon, because science obviously concerns itself with the study of natural phenomena. And the least in that hierarchy is sort of descriptive science, describing things and phenomena around you where the hypothesis is not tested. Now, this unfortunately seems to be the bulk of scientific research that is done in our country, descriptive, confirmatory, rather than the first kind, which is novel. When we are assessing scientific output, having already mentioned that there would have to be different parameters for other disciplines, we often talk about impact factors. Now, I know that all these are being debated all over the world, so we need not, really agree on whether this is the best way of assessing, but this is the commonly used way of assessing, which is, the impact factor, as all of us know, of course, is the, number of times papers published are cited from that journal within 2 years of its publication, and that gives it an impact factor. And there is something like an immediacy index, that is to say that if the published paper is quoted during the same year of publication, then it is considered to be, very topical, highly important. And then in 2005, everybody, of course, talks about the H index. Those of you who are mathematically inclined, this is actually the reference to the paper where it was published. But basically, an H index essentially is that, if the H of their n, papers is having at least, H citations, then, you would rate that as an H index. To put it in a simple language, it essentially quantifies both the actual scientific productivity as well as the apparent scientific impact of a scientist, which is, to give as an example, that if a scholar has an index of 40, that means that person has published 40 papers, each of which has been cited at least by other 40 people. Of course, self-citations are not included. So this, again, is something that not everybody agrees to, but it is a good parameter that by which we can actually assess the importance or the quality of scientific research, and also in, I understand, several other areas, social sciences and so forth. When we talk about scientific research, there is this famous kind of a diagram of what's called as Pastier's quadrant, which essentially talks about different kinds of scientific work. You could have, on this left-hand part of this quadrant, something that is pure research. Basically, what you're saying is quest for fundamental understanding, a quest for knowledge, quest for understanding. So, if you look at the work of, someone like Niels Bohr, this, would fall into that category. But then, did it, also have any consideration for use? That is, when the work was done, was it done because there was an application in mind? The answer in that case, of course, is no, which is pure basic science, which is what many of the scientists would pursue. Then there is another kind of work, equally important, which was pursued by the likes of people like Louis Pasteur, of what is called as, applied research sometimes, but it's kind of use-inspired basic research. As all of us know, what prompted Pasteur to actually do the kind of work they did was from, a problem. And so this was what you might call as use-inspired research. And finally, you have an application that you want to find a scientific, you have an application in mind, and so Edison probably would be a good example. Now, while you have many of these different kinds of scientific research being done, it's quite clear that the diversity that exists not only between sciences and social sciences, but even within the practice of science itself. However, I would like to end by sort of making distinctions between these three different types of scholarship, which we must all keep in mind when we are talking about assessment and accreditation. First is, of course, new knowledge, which essentially is very important for the intellectual climate of a university, because universities are really about generating knowledge. So I think, therefore, the scholarship of discovery is of utmost importance in a university context. But what is becoming increasingly important, and sometimes in our assessments and so on, we are not paying as much attention to, is the scholarship of integration. The ability to be able, for example, to connect a scientific, discovery to a societal impact, which is why I think the humanities and social sciences become extremely important even for scientific research, because this is, I think, another unfortunate part of our, growth of education. If you look at the numbers, particularly from the mid-80s and so on, most expansion has been in technology-related areas, and therefore, I think this is something which has been neglected. And finally, knowledge, of course, applied to problems of consequence, which address both individual and societal needs, and also where societal needs inspire and challenge existing theories. The chairman has already signaled me to stop, so thank you for your attention. No, but as I said, this is more to kind of initiate a discussion on some of these things, because these are not answers, but these are some of the questions that we can, the collective, try to address.